At this point, you probably think that graphing a quadratic is a little overwhelming, but you'll be happy to know that the axis of symmetry formula, the x equals opposite of b over 2a, is located on the ECA formula sheet, so you do not have to memorize that formula. As long as you know this formula, you can find out the vertex a little bit easier than having to memorize a formula. Let me show you. So first, let's fill in the formula x equals opposite of b over 2a with the equation that we are given. As long as it's in standard form, where it's set equal to y or equal to 0, then the coefficients of the x square is your a value, the coefficient of the x is the b value, and then your constant is your c value. So let's plug it in and solve for x. So we found the opposite of b, which is 4, 2 times a, which is 2 times 2 is 4, and 4 over 4 equals 1. So that's your axis of symmetry. Now, if you use your axis of symmetry, you can solve for the y value to figure out your vertex. This is instead of using that formula. So you just take your equation and you replace all the x's with the value that you just got from your axis of symmetry. Use your order of operations to evaluate it and solve for y. I'm going to stop right here. I want to show you what I did here. So I replaced all the x's with 1. I had to find what 1 squared was. And now I'm down here after I did 2 times 1 minus 4 times 1 minus 1. So I have 2 minus 4 minus 1. Looks like you have a subtraction of integers. So make sure you keep change on these. Keep change. There we go. So I have 2 plus negative 4 and negative 1 equals negative 5. So my y value is negative 3. Now I have an x value and a y value. I can figure out the vertex. The vertex is the one that's for my axis of symmetry, and then when I plugged it into the equation, I got the negative 3. A little bit easier? It's a little bit easier than having to memorize the formula because you can just use the equation to figure out the vertex. Now that we know the axis of symmetry and the vertex, you can also see if the equation tells you what the y-intercept is, which is always your constant value. So our y, well, here, let me plot the vertex of 1, negative 3. And our y-intercept is that constant value right there, y-intercept. So it's at negative 1. So the y-intercept is where it crosses the y-axis. We have 2 points of our graph already. Let's draw the line of the axis of symmetry. That's that vertical line that goes through the vertex. And we know, because our a value is positive, that this parabola is going to be pointing up. So looking at your y-intercept and where our axis of symmetry is, we know that there is another point on this graph that's exactly the same distance away on the other side of that axis of symmetry from the y-intercept. So if it's 1, then it should be right there. 1 away on the other side. Now we have 3 points and we know it's going up. We can do a quick sketch. Now my pen tool doesn't do a great job of drawing a curve, but again, this is just a sketch, an estimate. There we go. So there's my parabola that I just sketched. Remember that this should be a curve down at the bottom. Don't make this a strict V. Make it more like a U-shaped, but you want it to go through those points. Now my line didn't go exactly through the y-intercept, but on your graph you can erase and redraw it. Now a solution to a quadratic when you have a graph is the x-intercepts. When you have a sketch of the graph, wherever the line crosses the x-axis, those would be the solutions. Now it looks like one of our solutions at 2, the other one is about -0.5 in there. So you can use that to estimate your solution, especially if you have a graph and the problem is multiple choice, like most of them are on the ECA. Go ahead and do the next problem. Find the vertex, the y-intercept if you can see it, and do a sketch of the graph to see if we can estimate where the solutions would be. Okay, we're looking at problem 2. If you haven't done it already, you can push pause and try to give it a try as far as you can get. I'm going to go over the answers and you can push pause along the way if you need some time to write some things down. Alright, first I'm going to find out what my axis is symmetry. So x is equal to the opposite of b all over 2a. Opposite of b, well, b is negative 8, so I'm going to make a positive 8. 2 times a, which is 2. Simplify that, so that's 8 over 4. 8 over 4 is equal to 2. Next, I need to figure out what the vertex is. So I need to plug that axis of symmetry, that 2, into the original equation wherever I see an x. Simplify it to calculate y. Well, 2 squared is equal to 4. Copy the rest of the equation down. No, I did it. 8 times 2 is 16 there. 2 times 4 is 8, minus the 16 plus the 7. I'm going to do something different here probably. There we go, we have a keep change there going on. So I have a positive 8, a positive 7, and a negative 16. Well, I know that 8 plus 7 equals 15, that's positive. And negative 16 plus 15 equals negative 1. Now you could have solved that your own way by combining it whichever way you find easier. You could have done it 8 minus the 16 and then plus the 17. But that's just one way that I did it. The vertex then is equal to 2 comma negative 1, and you can plot that. Looking at the equation, you can see that the y-intercept is positive 7, so I plot that. Using my axis of symmetry that goes through the vertex, I can figure out another point on the line because it's going to be equally distance away from the axis of symmetry, that y-intercept is. So I have another point exactly the same distance on the other side, 2 away. Then I can sketch my graph, and where the graph crosses the x-axis, there's my estimated solutions to this parabola, or this quadratic. Alright, you do the next few problems here and I will show you your answers after each one. Okay, take a look at question 3. Your x-intercept, opposite b over 2a, is equal to negative 2. Use that negative 2 and plug it back into the original equation to solve for y. Negative 2 squared is 4. That negative that came in front of it doesn't go away. Negative 4 times negative 2 equals a positive 8 minus 1. Negative 4 plus 8 is positive 4 minus 1. And 4 minus 1 is 3. Therefore, your vertex is negative 2 comma 3. You can plot that point, negative 2. Oops, I have that in the wrong spot. Just a second. There we go, there's negative 2, 3. Then I notice that my y-intercept should be at negative 1, so on my y-axis I plot that negative 1. If I draw my axis of symmetry here, I know that there should be another point equal distance away from that axis of symmetry from that y-intercept. So there should be another point right there. Now I can use those 3 points to sketch the graph. That. And use that to estimate the solutions to the quadratic is where the line crosses the x-axis. So those 2 points right there. Oops, sorry. Okay, so that's what your graph should look like. And you have your x-intercept, your vertex, the sketch, and you've plotted your x-intercepts. Go ahead and try number 4, see how far you can get on your own. Alright, you ready to go over number 4? We start off with finding the x-axis of symmetry. So opposite of b over 2a, fill it in, negative 8 times 2 times 2. So negative 8 over 4 equals negative 2. This problem, as I was working it out, seems very familiar to another one. I almost think that it's the exact same problem. I don't know. I haven't looked back yet. Alright, I take that -2 and I plug it into the original equation. 2 times -2 squared is 4. -8 times -2, or I'm sorry, +8 times -2 equals a -16 plus 7. 2 times 4 equals 8 minus 16 plus 7. I'm going to combine my two positive numbers first to get a +15. Here's where I said, gee, this looks really familiar. I think we did this exact same problem before like this. So my y value equals -1. Therefore, your vertex should be at -2, -1. Plot that point, -2, -1. Look for the y-intercept in the equation, which is that +7, so I plot that point. If I draw my axis of symmetry here, then I know that there should be a point exactly equal distance away from that y-intercept. There's my 3 points that I can use to draw the sketch of the parabola. And the parabola crosses the x-axis there and there. So I identified where the solutions could be located. And this is just an estimate with the drawing because our sketch is just a rough estimate of where the parabola would be drawn. In future lessons, we're going to actually be able to calculate those x-intercepts with the equation with factoring. Go ahead and do the remainder 4 problems. I'm not going to show you the answers on the video. Instead, it'll be a self-check and correct link. Good luck on these.